Hello, geometry. We're looking at similar right triangles in this lesson. And so we're going to be looking at, as you can see, this triangle is kind of built up with lots of different triangles. So I'll try to highlight some of them. Again, first off, I see my largest triangle is triangle ADC. And then I have a medium-sized triangle that goes ADB. And then I have my smallest triangle, which goes DBC. So I have three different triangles in this one triangle here. So I think that some of the best ways to go about solving these problems is to pull those three triangles out and draw them so that they look exactly the same. So again, if you look at where we highlighted side DC, in this example, side BC is in two of my triangles. So that's this side right here, and that shows up as a 13 here and as a 13 here. So again, in reference to where the right angle is, that's how we want to draw our triangles. So we don't want to be drawing some triangles that look like this, other triangles that look like this. When we draw them, we want them to look exactly the same with the right angle in the same exact spot. And so when I pull out this information, again, the question is find AC. Okay, well, I know that AC is this spot right here. So again, my whole goal is to set up a proportion. So I'm going to say, all right, if I'm looking at this largest triangle, I'm going to put side BC, which is 13, over AC. And then because it's similar, I'm going to look at my smaller triangle and say, okay, similar triangles have the same proportion. So that's like going to be the same thing as saying DC over BC. So now if I plug in those numbers, I get 13 over X equals 5 over 13. And once we start cross multiplying, 13 times 13 is 169 equals 5X. And when I divide by 5 on both sides, I get X equals 33.8. So my answer for AC, so I'm going to say AC equals 33.8. Now the second part of this question says to find BD. So again, I locate that and I say, all right, that's right here. Now I could fill in what I know. Again, I know that this is 33.8, but Mr. Larson prefers to just use the same triangle. So whatever triangle you know the most of, I'm going to use that triangle. So again, my goal is to set up a proportion, and I'm going to say, okay, DC over BC. So that was my top and then my hypotenuse, that was my base and my hypotenuse. So now I'm going to put my base of this triangle over my hypotenuse of this triangle. And again, so what I just thought, or what I just did here, this doesn't help us because I have two unknowns here. I have two unknowns. So I have to think about, how else can I figure out maybe one of these things? And what I know is, hey, we actually use side DB or side AB in our largest triangle right here. And we know that we can always find a third side of the triangle using the Pythagorean theorem. So I'm going to do my short leg squared plus my other short leg squared, which is AB. So I'm going to call this x squared equals my hypotenuse squared, which is 33.8. So again, 169 plus x squared equals 1,142.44. So I have to subtract 169. Again, strongly recommend that you're using a calculator to help you do this. And then we're going to get 973.44. And then to get this by itself, I need to take the square root. and I'm going to get x equals 31.2. So if AB is 31.2 here, AB is also 31.2 over here. Because again, if we looked at our original picture, they are the same line. So now we can plug in what we know. DC is 5, BC is 13, over DB is what we're trying to find, but we do know that AB is 31.2. So start cross multiplying. 5 times 31.2, 156 equals 13x. Divide by 13, and you get 12 equals x. Look at that. We got ourselves a nice answer. BD equals 12. Strategy, again, when you have these multi-layered triangles, try to draw them with the right angle in the same spot. So right angle in the same spot. So pull out each triangle, and in reference to the right angle, put them either in the bottom left or the bottom right or the top right, however you want to do it, so that you can compare each of these triangles. And the final part of this question says, find the area of triangle ABC. So that again is my largest triangle. That's this one right here. So the formula for a triangle, so area of a triangle is base times height divided by 2. My base is 13. My height is 31.2. And I need to divide by 2. So 13 times 31.2 gives me 405.6. And when you divide it by 2, you get 202.8. And then whatever my units squared would be. So a lot of work can go into these. Again, I could ask a lot of different questions in just this one problem. Okay, there's a lot of missing sides, but if we set up our proportions correctly, we can go ahead and solve it. Okay, so in this example, let's see here. We are trying to solve for x. So I'm going to start by drawing my largest triangle, which is going to be JML. I know that JL is 13. I know that JM is 12. And ML is 5. So that's awesome because we know 1, 2, all 3 sides. So that's going to be helpful. Now I'm going to choose my second size triangle, which is going to be JKM. Oops, that's not very good. So this is JKM. Again, looking at my right triangle. JK, I don't know what that is necessarily. KM, I know is X. And JM, we already knew was 12. And then my final triangle, my smallest triangle, if I draw that one out, I'm going to get M, K, L. LM is 5. KM is X. And I'm not quite sure what KL is. So again, my goal is to solve for X. I've got an X here and an X here. So whichever one I want to use, as long as I use this large triangle, because I know all 3 sides, I can set up my proportion. So I'm just going to do the purple one and the orange one, just because I can see that one right there. Again, you could do it multiple ways. So I'm going to say, all right, let's take side JM. Let's not use JM because the corresponding side to my small or my medium triangle, I don't know. So I'm not going to use JM. I'm going to use JL. So JL is 13 and ML is 5. And those corresponding sides on my medium triangle are going to be JM and KM. So when I plug those in, I'm going to get 13 over 5 equals 12 over X. 12 times 5 is 60 equals 13X. Divide by 13. And we get not a nice number this time. X is approximately 3 decimal places for your rounding. So 4.615. Looking at this problem, trying to find the value of each variable, what I'm going to try to do is pull out these 3 triangles and draw them separately. So I see that if I pull out my biggest triangle in red here, okay, my longest side is this bottom side. We're going to call that Z. Or excuse me, my longest side is the hypotenuse, which we're going to call it X plus 16. My middle side, or my second longest side, is Z. And then my shortest side is the height, which is Y. So I'm going to set that up for all of my triangles. So now I'm going to go through, I'm going to use orange. And again, I see that my hypotenuse of my middle triangle is Z. The long leg is 16. And the height is going to be 12. So as I go ahead and draw that, okay, it looks like something like this. So I've got 12, I've got 16, and I've got Z. And then my final triangle, as I'm looking at it, my smallest one, I've got X as my height, my smallest side. I've got the bottom leg as 12, and the hypotenuse is Y. So again, as I draw that, I've got X, oops, we want blue. I've got X, 12, and Y. So I think the first one that is easiest for me as I look at these to try to solve is I'm gonna start solving for X. So I'm gonna use this side and this side on my triangle, and I'm gonna say 12 over 16 on my middle triangle is equal to X over 12 here. 12 times 12 is 144 equals 16X. When you divide by 16, you get 9 equals X. That's helpful for us because we can actually plug that in right here, and we can say 9 plus 16, this side is now 25. And I'm going to put a 9 right here. Again, I always recommend you fill in what you know to try to help yourself out. Now, my next goal is to try to solve Y. And I see that I've got a Y right here and a Y right here. And now again, I don't want to use multiple things that I don't know, but technically this Y can be the same value. I do know this hypotenuse now, and I do know that this is a 9, not an X. So I can go ahead and use those two sides. Again, if I'm looking at my big triangle, I'm going to say, let's say Y over 25. So take the height over the hypotenuse. I'm going to say Y over 25 equals, in this case, it's going to be 9 over Y. So 25 times 9, let's see here. 25 times 9, I believe, is 225, which equals Y squared. And then to take the square root of those, we're going to get 15 equals Y. So I, again, fill in what you know. It's always easiest to do that. And so now when I'm looking at, well, you know, I kind of like using the small triangle. Now that I know that Y equals 15, I can use either side, 12 or 16. I'm going to use 12. I'm going to say 12 over Z equals 9 over 15. Now I'm going to multiply 12 times 15 gives me 180 equals 9Z divided by 9, and we get 20. Z equals 20. Just do a quick double check, verify. On all of my triangles, my shortest side was the height, the one that's going up, 15, 12, and 9. My medium side length was the bottom, 20, 16, and 12. And of course, my longest side was always my hypotenuse, 12, 20, and 15.